So this is where we left off yesterday. Yesterday I mentioned to you guys that the last thing in chapter 6.1 is, instead of ask you for the area underneath the curve, instead of ask you for the proportion of the population or the probability of the probability, they ask you now, what if they give you the percentage, right? What if they give the percentage and they ask you, they reverse and they ask you the z-score value or the x value or the item. So again, the last item I mentioned is, now if they give you the percentage, if they give you the percentage and you have to find the value, this is what you guys need to do, or this is what we need to do, is we need to do the inverse norm. And ladies and gentlemen, in chapter 6, the only two features that we're using with the calculator in chapter 6 is the normal CDF and the inverse norm, okay? That's the only two things we're doing, because chapter 6 is the normal distribution, which is, again, those are the two items with the normal distribution, is the inverse norm, which is they ask you to find the value, or the normal CDF, which is they ask you to find the percentage. And reminder that the inverse norm, the only thing that the calculator can calculate is the area to the left of the value. Whatever the value is, you need to give them the area to the left, the mean, and the standard deviation. And the other thing I want to stress out is, this is the two things that you need, ladies and gentlemen, in chapter 6. The two things that you need to calculate or to find anything is, you need the mean and you need the standard deviation, okay? So let's take a look at this thing here, which is, I have a small note, which is, when you do the homework over this weekend, once you finish with your midterm, and you do the homework on chapter 6.1 and 6.2, this is what you want to ask yourself, is what is the question asking me, or how do you determine when are you using the normal CDF and when are you using the inverse norm, right? So if the question asks you to find the area underneath the curve, if the question asks you to find the proportion of the population, or if they asking you to find the probability, that is when you need to find the area underneath the curve. That's when you use the normal CDF. And to do the normal CDF, reminder, you need the lower limit, the upper limit, the mean, and the standard deviation, which is the mean and standard deviation. As you can see, those are the two things that you cannot miss, or you cannot, you have to have it in order for you to calculate, as you can see, for both items. And when are we using the inverse norm is when they ask you for the z-score, find the z-score or find the x value, or if they give you the percentage, then that's when you find the inverse norm, or you use the inverse norm, okay? Or if they give you the percentile, which you will see later about the percentile. So this is basically just the two different items to use, or how to determine, do we use the normal CDF or when we use the inverse norm. So we did this problem yesterday, but let's go back to this problem that we have. And then again, this is what they ask you. This is the 3-step for you to do your inverse norm item, okay? So if they ask you this thing here, as I mentioned, find the z-score, right? So again, previous slide, they tell you if they ask you for the z value, which is in this case, they ask you for the z-score, that's what they do, right? And this is what they tell you is, find the z-score for which the area to the left of the z-score is equal to 0.13 or 13%. So looking at this thing here, like I mentioned to you guys on yesterday, this is what you want to do, is you want to sketch your item. And if you sketch your item, as you can see, this is our normal bell-shaped curve. And if we sketch this item, do you agree that this is what they give me, is they give me 0.13. They tell me that the area to the left of the z-score is equal to 0.13, which is, this is my 0.13 z-score, which is, again, not z-score, my 0.13 in terms of the percentage, which is, again, once I have this thing here, again, all we need to do is using the inverse norm, which is the area they give me, which is the area to the left. All I need to do is put 0.13. And ladies and gentlemen, the area right here, as you will see is when you type in your calculator, this area will never be bigger than 1, okay? Because the area underneath the curve, the maximum is 1. So if you put in 13 or if you put in 5 or something as the area, they will tell you it's the error. They will tell it's wrong, okay? So again, this is reminder, you hit second VARS, var, and then you choose the inverse norm, which is now, this is what you have. You put in 0.13, comma, 0, comma, 1, which is because of the z-score, which is the standard normal, your mean is 0 and your standard deviation 1. Once you plug on that, this is what you should get. And I mentioned last time that this thing here, because they give you the area to the right, which is the area to the right is 0.05, but your calculator cannot calculate the area to the right. You need to tell them, or you need to take 1 minus that area of the right to give you the area to the left, right? Subtract from 1, which is, this is what I did. I take 0.05, subtract from 1, which is 1 minus that to give me 95, which is 95 is here. So now I put in inverse norm 0.95, comma, 0, comma, 1, which is, again, this is what I have, which is 1.645. So this is what your obstacle for the inverse norm is. You need to ask yourself is, do they, or they give me the area to the left or the area to the right? They will give you the area. You have to know if it's area to the left or the right. So let's take a look at the next example. We did this yesterday. Let's take a look at this thing here, which is, like I mentioned to you guys, ask what the question give you or what the question asking you, right? So this one here, they say the normal population, and again, the only reason why they say normal population is basically we are dealing with a normal distribution, a bell-shaped curve, right? So a normal population have the mu of the mean mu equal to 67 and the standard deviation of 4. What is the 45th percentile of the population? So looking at this thing here, if you remember the percentile is basically, remember in chapter 3, the percentile is your data. We slice them 99 slices, which is we have 100%, right? The percentile is basically, again, for instance, if we have 100 people, the 45th percentile, meaning you score on the 45th, you are the 45th person, and there are 44 people below you. Or in the center of this thing here, percentile is basically is the same as tell you that they are a 45%, right? So looking at this thing here, if you sketch in this thing, percentile is just another word that the area percentage to the left. Just imagine that this thing here, we cut up 199 times, right? And again, the 1%, the 2%, the 3%, the 4%, the 5%, and all the way up to the 45%, which is, again, the 45 percentile is basically tell you that they give you the 45% to the left, or in this case, 0.45 on the left side. And again, if this is 0.45 on the left, which is, again, if we know that this is the area on the left, then all we need to do is put in the inverse norm, which is, again, if you put in the inverse norm, you need the area to the left, the mean, and the standard deviation, which is, in this case, if you type this in your calculator, you will have 66.4974. And again, or probably 66.5 if they ask you for 2 decimal places. Okay, so again, looking at this thing here, hopefully you guys see that percentile is just another word for the percentage to the left of a given value. Okay, and again, to sketch this thing here, it doesn't have to be exact, right? Some student asked me, how do you sketch them? Well, just imagine, well, not this one here. Just imagine if you have a empty, you know, just draw like a mountain, and you just draw a line straight down, right? And you ask yourself, which percentage do they give me, or do they give me on the left-hand side or on the right-hand side of that line, right? Let's say you draw this small mountain and then you just draw a straight line. Doesn't matter where your straight line is, you just draw a straight line, right? And then you ask yourself, okay, which way am I shading? Do I shade on the left or on the right, right? So again, if you determine that, just shade on the left, on the right, and that's how that's how you sketch this. It doesn't have to be precise. It just give you an idea of what type of information they give you in that sense. Okay, but again, let's go.
How do we know that that's on the left?
Percentile?
Yes.
It's just another word on the left.
Okay, so percentile means on the left.
Yes.
Okay.
If you remember in chapter 3, we cut our slices into 99 slices, like the 1%, the 2%, the 3%. Right? So that's the percentile, meaning you split your data into 100 different percent. And the percentile is basically tell you that the accumulation of the percentage from 0 up to that percent. So the accumulation from the left to that percentage or to that position. So that's what percentile is. Okay. So like I said, it's just a fancy word in terms tell you that is the percentage to the left. I mentioned this on chapter 3 is if you go take the ACT and let's say there's 100 people, and then when you receive your score, they say you are on the 95 percentile, meaning of that 100 people, you are the 95th person, right? Meaning your score is very high, you are above 94 other people. That's what 95 percentile is, right? So it's basically is compared to from 1% up to that percentage. Okay. So same idea go, which is for number 2, they ask you with the same mean and same standard deviation at part A, what is the 92 percentile of the population, which is 92 percentile. The 92nd percentile is the same from 0 up to 92nd, which is we know that this is the area they give us, which is if we can identify that is the area, which is that is the area to the left of your point that we're looking for, right? So looking at this thing here, which is 0.95 is the item on the left, which is now we need to put in my inverse norm, and this is what we have. Okay, so again, this is basically, whatever information they give you. For instance, let's say, let's look at C, right? Given the data in part A is the result of test 1 in the statistic class, right? What grade will we consider to be a top 7%? Okay, so we know that if we were to, if from left to right, small as we go to the right, we increase in terms of the better the score is, right? If you're in the middle, you are on the 50%, which is the average. So how can we consider the top percent? How can we consider top 7%? Which is, do you agree that the top 7% is pretty much this thing here, which is if you score very high, then you will score over here. And if you are in this area, which is the green area here, you are in the top 7%, right? The bottom 7% will be here. The top 7% will be here, right? The middle will be somewhere here, right? So this thing here, if they give you the top 7%, which is, we know that this is the top 7%, which is in this case, do you agree that 0.07 is the percent on our left-hand side? I mean, on right-hand side, right? So our calculator can only calculate to the left-hand side of that item, which is now, if you see that this is on the right, we need to take 1 minus that to give us 0.93 is on the left-hand side, which is because of the calculator. That's why we need to do this thing here, which is 93% is the percent on the left. And that is the 93% that I'm using in my inverse norm, right? So looking at this thing here, as you can see, if you score, if you need to, based on this information, the mean, the average is 67 and the standard deviation is 4, which is the spread out is not that big, you need to score 73, right? Based on this information, you need to score 73 to be considered in the top 7%, right? 72.9, so if you score 72.93 or something like that, you are in the top 7%, okay? So looking at this thing here, and let's say we have the same item here, right? what does the 92 percentile mean? Meaning again, as you can see, this thing here, your score on this particular test, if you score 72.62 on this test, you are 92 percentile. Meaning again, it's not that you score 92 on the test. Your test score is only 72.62, right? But if we have 100 people took the test and you score 72.62, meaning there are 91% score less than you, right? It's not the 92 percentile is not the percent you score on the test. The 92 percentile is basically tell you what position among the people that took the test, right? So as you can see, in terms of that, that's what we have in terms of the percentile is basically the position of the item, position of the data. But what is the actual data? The actual data is just 72. You can see that the score is very low, right? Because of this thing here, the spread out is not that big. The spread out, the standard deviation is only 4, meaning very clear, like many people score around the mean, right? The mean, and the mean is 67, which is the score is not that big. And if you score 72.9 or 73, you are in the top 10, or not top 10, top 7%. Okay, so that's the idea here is if they give you the percentage, how can you find the actual data itself, right? But again, one thing is to find the inverse norm. To find the inverse norm, like I mentioned, we need the area, which is your calculator can only give you the area to the left, and the mean and the standard deviation. So let me stop for a bit and ask you guys, question with A, B, or C here, how to determine which one to use, or how to determine how to sketch your normal distribution. All right, if you don't have a question, let's take a look at this problem here, which is if you did the homework, you probably run into, well, not this problem, the next problem. Let's try this problem, which is, again, I want to throw this problem at you just in case you did your homework and you run into the quartile, right? If you run into the quartile, you probably, again, quartile is the same as before. It's just a fancy word, right? So looking at this thing here, this is the story they give you, right? A report from the poultry site state that the weight of the broiler commercial raised chicken are approximately normal, which is, again, basically they tell you that it's a bell-shaped curve. With the mean, we need a mean, which is the mean is 1387 gram, and the standard deviation is 161 gram. So again, the spread out is a lot, 161, right? So looking at this thing here, they actually find the 93rd percentile of the weight, right? So what is the chicken weight have to be considered at the 93rd percentile, right? So looking at this thing here, which is, again, 93rd percentile, like I mentioned, the word percentile is basically the area to the left, right? The area to the left, which is 93rd percent, which is, again, if we know that the area to the left, life is good, we just convert this percentile to a decimal, and then we type in our calculator, which is the inverse norm, 0.93, comma, the mean, which is 1387, comma, 161, which is the chicken have to be weighed 1624.6, right? Meaning, again, gram, right? The chicken, if they weigh this much, then we consider that chicken in the 93rd percentile, okay? If they weigh more, well, it depends on how many chicken they have, right? So again, the percentile is that, and similarly to the percentile, the quartile, a first quartile reminder, what is the difference between percentile and quartile? Well, the percentile is you split in each 1%, 2%, 3%. The quartile is, instead of split into 99 of them, you only split in 4 of them, which is the first quartile is 25%. The second quartile, which is the median, is 50%. The third quartile is 75%, right? So the first quartile is basically, again, quartile basically is the same as a quarter. So the first quarter is basically 25, which is again, quartile or percentile is the same. It's basically tell you that the area to the left. And in this case, if we know the area to the left, all we need to do is put in our inverse norm, which is again, if the chicken weight 1,278.41 gram, that will be in the first quartile, or we can say 25 percentile. It's just different wording, but hopefully those wording don't confuse you. It's just a fancy way to say that the percentage to the left of the value. Okay, so looking at this thing here, they critical thinking and ask you, a chicken farmer want to provide a money back guarantee that his broiler will weigh at least a certain amount. What way should he guarantee so that he will have to give his customer money back only 1% of the time? Meaning again, now how much would you say, you say my chicken will weigh at least this. If it's less than this, I will give you the money back. So this farmer say, okay, what is the standard weight that I should say that my chicken, if you buy my chicken will weigh this much. And if you bought the chicken, you go home and you wait and it does not meet that requirement, you return to him, he will give the money back. So they ask you, what is the weight that the farmer should state, right? So reminder, so now you have to ask yourself, well, what is this 1%? Is this the, is this the 1% to the left or 1% to the right, right? So imagine if this were to be the item, we have to, if the chicken weigh less than this weight, then the farmer have to give the money back, which is in this case, everybody see that this is the 1% that he have to give the money back. The other 99% he will keep the money, right? So basically we want to know what is the minimum weight, what is the lowest weight that he need, which is again, as long as this cover 1%, which is 0.01, if it's covered the 1%, then we're good to go, right? Which is this 1% is the percentage to the left. It's not the top 7% like earlier. This one is the 1%, is the 1% to the left, which is again, if we know the percent to the left, we put in the inverse norm, 0.01, 13, and then 1387, and then comma 161. And again, this is the minimum weight, which is the farmer will say, my chicken will weigh at least 1,013. Just make it even, 1,013 gram. If you go home and you weigh your chicken, that the chicken is less than 1,013 gram, I will give you the money back. Okay, so again, that's the idea here is how can we find the data? How can we find the weight of the item, which is in this case, the weight is the data, right? So the inverse norm tell you how to find the weight or how to find the data itself, okay? So question with this item here. So let's put all of this together in terms of 6.1. And again, this is probably the hardest problem you will hit or you will see in 6.1, which is if you did the homework already, you probably saw B and C, right? But let's take a look at this thing here. Reminder, I told you guys, right? When you read this thing here, looking at this thing here, we know that they give us the mean 25. We know they give us the standard deviation 7, right? We know that the data is normally distributed. And again, everything else is just, they can make up whatever the data they want, right? They can tell you that this is how many days in the month or whatever, right? So if this is the data, is how much do you study? That's the title of the problem. A survey among the freshmen at Southern University reviewed that the number spent on study the week before the final exam. So again, this is just the week before the final exam, are normally distributed with the mean of 25 hours and the standard deviation of 7 hours, right? So the week before the final exam, they focus in and study, and they study 25 hours on average, okay? So now, this is what you have is A, B, and C, they ask you, what is the probability? We can stop here, ladies and gentlemen, because remember, if they ask you what is the probability, are we using the inverse norm or the normal CDF, right? So this is here, they ask you what is the probability that a random selected student spend between 15 hours and 30 hours of studying. So looking at this thing here, they don't give you the percentage. They don't give you the percentile, and they don't tell you anything in terms of the percent, right? But again, you should know that they ask us what is the probability, and because they ask us what the probability, we should know, or you guys should know, make a note for yourself, is we need to use the normal CDF. So to find the normal CDF, we need two things, right? We need two things, which is the two things we need for every problem is we need the mean and we need the standard deviation. And the other thing that we need for the normal CDF is we need the two endpoints. We need the lower limit and the upper limit. Do you agree that this is the percentage that we're looking for? The area, the probability underneath the curve, which is between 15 and 30. So looking at this thing here, if you remember, this is what we need to do is we need to type in normal CDF. My lower limit is 15. My upper limit is 30. The mu is 25 and the standard deviation is 7. So looking at this thing here, this is what we need to do because they don't give me the percentage. They ask me for the percentage, or they ask me for the probability, which is in this case, this is what I need to do. I plug it in. I know that 68% or 0.6859, roughly 68.6% of the student will study between 15 hours to 30 hours, right? So again, that's not, the question is, if you go in here, if you go to this university and pick one person, what is the probability of that person study between 15 hours to 30 hours the week before the final exam, which is the probability, the chances of that person study between 15 to 30 hours is 68.6% or 0.6859. Okay, so this is the chances, this is the probability, this is the percentage, this is the proportion. That's what they ask you, which is the area underneath the curve. So the other one, which is again, B and C are very identical. So let's attack B first. Hopefully you can see. So looking at this thing here, the difference between this item, if they give you the percentage, we know that we have to use the inverse norm. To use the inverse norm, we need to know the area to the left. But what are they giving me? They did not give me the area to the left. They did not give me the area to the right. They give me the area. They asked me between what two value. We need to know what 2 hours or the middle 80%. So this is what they ask you is, I want this item right here in the middle, smack in the middle is 80%. Everybody see that again. I want to know between what 2 hours, what two value is considered to be the middle of the pack, the middle 80% of this population. So we know that between these two values, 15 and 30 is only 68%. That's 69% to increase it to make sure, right? So between this 2 hours, the previous problem is only cover 69%. Now this thing here is the middle 80%. Everybody see that? So looking at this thing here, do you agree that the maximum in the middle is 80%? The maximum area underneath the curve is 100%. And if I take 100% minus the 80, I will have 20% left. But because it say the middle 80, meaning I have two tail later on in chapter 8, you hear me this left tail and the right tail, right? So because I have two tail, I have to take the 20 and divide by 2, which is I have 10% here and 10% here, which is the 10%, the 80%, and another 10%. Everybody see that that is 100% of my population, or 100% of the area underneath the curve. Okay, so again, because they give me the middle, I know the middle is 80. the leftover two endpoint will be 10% and 10%. Why do I need this? Because remember, to find the area, or not the area, to find the inverse norm, I need the area to the left. So this endpoint, I know that from here to here is 10%. So all I need to do is put an inverse norm, 0.10, comma 25, comma 7. And once I have that, which is again, my left endpoint is 16, right? And again, my right endpoint here, how do I find my right endpoint here? Well, my right endpoint, do you agree that the 10% plus the 80%, that is the area to the left of this endpoint? We cannot do the other 10% because the other 10% is to the right, right? So do you agree that this number, to find this number, the left area is 90%. The 10 plus the 80, that is 90%, which is to find this thing here. I know that the two number, this number right here, ladies and gentlemen, as you can see, this two number that we're looking for is this, which is again, the left endpoint. Let's just say this thing here is 16.03. And on the right-hand side, the number on the right-hand side is 33.97. So those are the two endpoints that we have. Those are the two items that we have, which is again, if you were to take this number, if you were to do the normal CDF and then 16.03, comma 33.97, comma 25, comma 7, you will get 80% or 0.80, right? So again, this is just the inverse. The reason why we have to do this is because they did not give us the left side, or they not just give us the right side, but they give us the middle. And because they give us the middle, we have to divide the leftover into two. That's why we have two tail on this side of the two tail. So again, question with this thing here, question with how I have the answer first, or how did I come up with this answer 16.03 and 33.967. Okay, so let's try another one, right? Let's try this, C. Instead of 80%, now they say that the middle of 76%. So if you take a look at this thing here, which is the middle is 76%, right? I just do different color. It's just the same graph. I just do different color. But again, do you agree that the middle is 76? So I have to take 100, which is the maximum percentage, minus 76. Therefore, I have 24, right? 100 minus this to give me 24, but I need to take 24 divided by 2 to give me 12% on each side. So I have 12% here and 12% here, but I don't really need this 12%. I only need the 12% to the left. Everybody see where I get the 12% from, right? The 76, 100 minus 76, the result divide by 2 because we have two tail. And then once we have that, which is the first endpoint is 16.78, and the second endpoint will be 0.88 because I have to take the 0.12 plus the 0.76, right? The 12 plus the 76 to give me 88, which is 0.88. And as you can see, this interval, which is chapter 7 confident interval, this interval is smaller, right? If we were to say this is 16.8 and then 33.3 is smaller than 16 and then 34, right? 16 and 34 is wiser, is bigger because it covers more area. That's why the interval is bigger, right? This one here, the interval is only 15. Everybody see this interval here. From 15 to 30, there's only 15, which is, again, there's only 69%. From 16 to 34, that's 18 units. That's why it's covered 80%. And again, this thing here is a little bit smaller than that. That's why it's only covered 76%. Okay. So again, that's the idea here in terms of chapter 6.1 is you either have to find the probability or you have to find the actual data. And again, if they ask you to find the data, we do the inverse norm. If they ask you to find the probability, we use the normal CDF. Question with this particular problem, and again, someone sent me an email about this problem B and C, so hopefully after this you guys can do it on your homework. I think they say like 90% or 86%. I don't think they used 80 or 76. I use a different number so that you can see what to do in terms of your homework. Question with this A, B, or C here, ladies and gentlemen.